Right now, as you listen to these words, something is happening that has caused astronomers around the world to drop everything and point their telescopes at a single point in space. 3I Atlas, an interstellar traveler that has already baffled us with its impossible chemistry and ancient origins, has just done something completely unexpected. Something has come out of the comet, and it's moving in our direction. On September 28, 2025, the Pan-STARRS telescope array in Hawaii recorded an anomaly that should not have existed. A distinct secondary object separated from the coma of 3I Atlas, the cloud of dust and gas surrounding its nucleus. It was not a fragment from the comet's disintegration, which would have been a completely normal phenomenon. No, it was something else. The object was moving along its own trajectory, different from that of its parent comet, with an acceleration that cannot be explained by simple gravitational interaction or solar radiation pressure. For the first 72 hours after its discovery, the scientific community was in a state of controlled chaos. The Gemini Observatory in Chile, the James Webb Space Telescope, the Very Large Telescope, all of the planet's largest instruments were redirected to track this new mystery. And as more data came in, the story became even stranger. Stay with me on this nighttime investigation to understand what we're really dealing with and why the silence of some space agencies may be the most disturbing part of this whole story. Part 1. Discovering the impossible. To understand why the discovery on September 28th is so significant, we need to recall what we already knew about 3I Atlas at that point. The interstellar comet, discovered on July 1st, 2025, passed through perihelion at the end of October, and as planned, reappeared from the glare of the sun in early December. Spectroscopic analysis revealed its incredibly anomalous chemical composition, an extreme ratio of carbon dioxide to water vapor, unusual emission lines of nickel with an almost complete absence of iron, and organic compounds not found in any comet in the solar system. But the comet behaved predictably. Yes, its chemistry was alien. Yes, its age was estimated at more than 7 billion years, but it followed the laws of celestial mechanics with mathematical precision. Its hyperbolic orbit was calculated with a high degree of certainty, and every observation confirmed these calculations. 3I Atlas behaved exactly as an interstellar comet passing through the inner solar system should behave. And then everything changed. Dr. Marina Broderick, lead astronomer for the Pan-STARRS team, first noticed the anomaly during a routine review of observation data. At first, I thought it was an image processing artifact, she reported in her initial report to the International Astronomical Union. A small bulge at the edge of the coma, possibly a jet of gas ejected from an unevenly heated surface of the nucleus. This happens all the time. But when she applied point source extraction algorithms, the math told a different story. It was not an artifact. It was a separate object with measurable proper motion relative to 3I Atlas. Over the next 6 hours, the Pan-STARRS team obtained a series of confirmatory images, each showing that the object continued to move away from its parent comet. By the time dawn broke in Hawaii and the telescopes stopped observing, the object had moved about 12,000 kilometers away from the coma of 3I Atlas. But this is where the story gets really strange. The separation velocity was too high. When comets eject fragments as a result of internal stresses caused by uneven heating or explosive sublimation of volatile ices, the physics of the process is well understood. The typical ejection speed ranges from a few meters to a maximum of several tens of meters per second. This is due to simple thermodynamics. The gas pressure created by sublimating ice can only provide limited momentum to the fragments of the nucleus. The object that separated from 3I Atlas was moving at a speed of approximately 180 meters per second relative to the comet. This is 10 times faster than any natural fragment of a comet should move. It is as if something did not simply eject this object from the comet, but actively accelerated it in a certain direction. When European telescopes came into play after sunset in the Pacific region, the Very Large Telescope team in Chile provided the first spectroscopic data on the mysterious object. The results were puzzling. The reflection spectrum did not match that of either rock or ice. Instead, there was a relatively flat reflectivity in the visible range, with unusual absorption features in the near-infrared spectrum. This does not look like typical cometary material, noted Dr. Javier Lecandro of the Canary Islands Institute of Astrophysics in a confidential memo that later leaked to the astronomical community. The spectral signature suggests a surface with low albedo, very dark, but with reflective properties that do not match known classes of asteroids or comet nuclei. If I had to guess, I would say I'm looking at something artificial, but that's impossible. It was this last sentence that sparked a wave of speculation that quickly spiraled out of control on social media and astronomy forums. Artificial, a word that no serious astronomer would want to utter publicly, without extremely compelling evidence, suddenly found itself at the center of the discussion. Part 2. A trajectory that doesn't make sense. As additional observations accumulated over the next week, it became possible to calculate the orbit of the detached object with reasonable accuracy. And this is where the situation escalated from a curious anomaly to something requiring urgent attention at the highest level. The object was not following the simple ballistic trajectory that would be expected from a passive fragment ejected from a comet. Instead, its path showed signs of ongoing non-gravitational acceleration, a subtle but measurable deviation from what purely gravitational models predicted. Moreover, the direction of this acceleration was not random. The object was adjusting its course. There are well-understood mechanisms to explain non-gravitational acceleration in comets. When volatile ices sublimate from the rotating surface of a comet, jet streams of gas are created that can alter the object's trajectory like tiny rocket engines. This effect, known as non-gravitational forces, has been observed in many comets and has been thoroughly studied. But the object from 3I Atlas exhibited an acceleration pattern that did not correspond to cometary activity. First, spectroscopic observations showed no signs of gas outflow, no expanding coma, no dust emission, which characterize active comets. The object was relatively inert in terms of visible gas emission, and yet it was accelerating. Second, the direction of acceleration was changing. During the first 5 days of observation, the object made 3 separate course corrections, each of which slightly altered its trajectory. Such behavior is unprecedented for natural bodies in the solar system. The NASA Orbital Dynamics team at the Jet Propulsion Laboratory conducted a comprehensive analysis of all possible natural explanations. Could solar radiation pressure explain the observed acceleration? Only if the object were extremely light and had a large surface area, essentially a solar sail. But size estimates based on the object's brightness suggested something much denser. Could internal thermal activity, the slow release of heat absorbed during its passage near the sun, create subtle jet effects? Perhaps, but again, the absence of detectable gas outflow made this mechanism highly unlikely. Furthermore, the acceleration pattern was too directional, too purposeful, to be the result of random thermal gas release. Then, on October 5th, something happened that turned a scientific puzzle into a potential crisis. The object changed course for the 3rd time, and this time, analysis of the trajectory revealed something disturbing. The corrected orbit now crossed Earth's orbit. It should be made abundantly clear what this means and what it does not mean. The object was not on a collision course with Earth, at least not according to current predictions. Orbital intersection is a geometric concept. 2 orbits intersect in space, but the objects following those orbits may be in completely different locations when they reach the point of intersection. It's like 2 cars using the same intersection at different times. The paths cross, but there is no collision. However, what made this situation alarming was that the object appeared to be actively maneuvering. If it could adjust its course 3 times, it could do so again. And each adjustment made its trajectory less predictable. At a closed meeting of NASA's Planetary Defense Coordination Office on January 25th, Director Dr. Lindley Johnson presented a sober assessment. We have an object of unknown origin and composition, showing clear evidence of directed acceleration, moving on a trajectory that crosses Earth's orbit. Although current calculations do not indicate an immediate collision threat, the object's maneuverability means that we cannot predict its future behavior with certainty. This is an unprecedented situation. Part 3. Properties of the object. While astronomers and planetary defense experts tried to understand the object's trajectory, another group of researchers focused on trying to determine what exactly this mysterious wanderer is. Estimating its size proved to be a surprisingly difficult task. Astronomers typically determine the size of a distant object by measuring how much sunlight it reflects and then making assumptions about its albedo, the reflectivity of its surface. A dark object should be larger than a bright object of the same apparent brightness. The problem with the 3-eye Atlas object was that its spectral properties did not match any known material, making albedo estimates extremely uncertain. Initial calculations suggested a size somewhere between 50 and 200 meters in diameter, a range so wide as to be almost useless for understanding the nature of the object. The breakthrough came when the James Webb Space Telescope conducted a series of thermal infrared observations on October 2nd. By measuring the object's thermal radiation, the heat it emits, rather than reflected sunlight, much more accurate size estimates can be obtained, independent of the surface albedo. The results were unexpected. The object was relatively small, about 85 meters long along its longest axis, but its thermal signature suggested an uneven temperature distribution. One side was significantly warmer than the other, which is unusual for a passive object rotating in space, which should heat up relatively evenly on all sides facing the sun. The thermal distribution suggests either an object with a highly thermally conductive side and an insulated side, or an internal heat source, concluded the JWST team's analysis. Neither explanation easily fits with natural geological materials. The shape of the object added another layer to the mystery. Analysis of the light curve, how the object's brightness changes over time as it rotates, suggested an elongated shape with an axis ratio of about 3:1. Not quite cigar-shaped, like the infamous Oumuamua, but definitely elongated. The rotation period was approximately 6.3 hours. Not too fast, not too slow, but stable enough to indicate a solid body rather than a loose collection of debris. The most puzzling characteristic was the object's low reflectivity, combined with its strange spectral features. When the Hubble Space Telescope obtained a high-resolution spectrum, the data showed absorption features that could correspond to complex carbon compounds, possibly mixed with silicates and metallic components. But the exact mineralogical composition remained elusive. It's not like a C-type asteroid, it's not like a comet nucleus, and it's not like any meteorite in our collection, noted Dr. Alan Fitzsimmons of Queen's University Belfast, an expert in small body spectroscopy. If I encountered this spectrum in a laboratory setting, I would suggest a mixture of materials processed in conditions not found in asteroids or comets. Perhaps something that has been exposed to extreme radiation for billions of years in interstellar space. But even that doesn't quite fit. By early February, a portrait of the object was emerging that only added to the mystery. An elongated solid body the size of a small asteroid, composed of an unknown mixture of materials, exhibiting uneven heating, moving along a changing trajectory, using an unknown mechanism of motion. Each new batch of data seemed to raise more questions than it answered. Part 4. Silence from the authorities. Perhaps the most disturbing aspect of the whole situation was what was not happening. Public statements from major space agencies, NASA, the European Space Agency, even private space companies with deep space capabilities, remained unusually silent about an event that should have dominated the science news. The usual procedure for potentially hazardous near-Earth objects is well established. When a new asteroid is discovered that may pose even the slightest risk of collision, the information is quickly disseminated through the International Asteroid Warning Network. Public risk assessment systems, such as NASA's Sentry and the European Space Agency's NEOCC, are regularly updated with collision probability estimates. Press releases are issued regularly to explain the situation in accessible terms. But with 3I Atlas, a different protocol was followed. The initial discovery on September 28th was posted to the Minor Planet Center, the standard procedure for any new discovery, but subsequent trajectory updates, signs of non-gravitational acceleration, and a potential intersection with Earth's orbit did not receive the usual public coverage. Instead, the information was disseminated through unofficial channels, leaks from researchers involved in the analysis, discussions on closed scientific forums, and fragmentary reports from amateur observers who tracked the object on their own. An information vacuum was created, and as is usually the case with vacuums, it was quickly filled with speculation. On October 4th, an anonymous post on a popular astronomy forum claimed that NASA had held several closed-door meetings involving not only planetary scientists, but also representatives of the Department of Defense and the intelligence community. Although unconfirmed, the post contained enough specific details, dates, names, topics for discussion, to suggest that the author had access to insider information. They don't know what it is, the post claimed. Every natural explanation has been checked and rejected. Directed acceleration, thermal anomalies, spectral characteristics. None of this is consistent with known physics of small bodies in the solar system. And if it's not natural, then there's only one conclusion left, which no one wants to say out loud. Regardless of whether the specific post was accurate, it reflected a growing unease within the astronomical community. Private conversations among researchers, usually accessible through professional networks, became noticeably cautious. Requests from science journalists were met with evasive answers or ignored altogether. On October 5th, NASA issued a brief statement acknowledging the object's existence and confirming that it was being monitored, but provided minimal additional information. NASA is tracking a small object that appears to have separated from the interstellar comet 3I Atlas. Current orbital calculations indicate no immediate threat to Earth. We continue to monitor the object and will provide updates as more information becomes available. The statement raised more questions than it answered. What did appears to have broken off mean? Why was there no mention of non-gravitational acceleration? What did immediate threat mean? Did it imply a potential delayed threat? The silence from other space agencies was even more complete. The European Space Agency, usually open about asteroid hazards, issued no public statements about the object. Roscosmos, JAXA, CNSA, all the major space programs remained silent, which in itself was unprecedented. Some observers interpreted the silence as a sign of coordination, possibly indicating that governments were discussing the situation behind closed doors before deciding how to inform the public. Others saw it as simply a lack of information. Perhaps the agencies did not want to cause public alarm over a situation they themselves did not understand. But in an era when amateur astronomers with decent equipment can track near-Earth objects on their own, complete secrecy was impossible. Multiple independent observers confirmed the object's existence, its unusual trajectory, and its continued non-gravitational acceleration. The data was there for anyone with a large enough telescope and the desire to look. Part 5. What could it be to date? Several competing hypotheses about the nature of the object have emerged in the astronomical community, each with its own supporters and problems. Hypothesis 1. Exotic cometary activity. Some researchers have argued that the object may be a fragment of 3I Atlas with an unusual composition that produces low-level cometary activity undetectable by modern instruments. Perhaps the outflow consists of compounds that do not glow in the usual spectral ranges, or the jets are so narrowly focused that they appear as a point source rather than an expanding cloud. The problem with this hypothesis was the directional nature of the acceleration. Cometary jets typically produce chaotic trajectories due to core rotation and uneven gas emission. 3 separate course corrections, each of which seemed to steer the object in a specific direction, were difficult to explain through natural cometary activity. Hypothesis 2. Interstellar artifact. A more speculative but increasingly seriously considered explanation was that the object might be artificial, a remnant of extraterrestrial technology. Its separation from 3I Atlas could be interpreted as activation after a long period of dormancy, possibly triggered by solar radiation or proximity to a star system. This hypothesis would explain the directed acceleration, motion system, thermal anomalies, internal energy sources, unusual composition, engineering materials, and elongated shape, optimized for interstellar travel. It would also explain the silence of space agencies. Such a discovery would require extremely careful handling. The problem, of course, is that extraordinary claims require extraordinary evidence. The entire history of the search for extraterrestrial intelligence has taught us that nature is capable of producing incredibly strange phenomena without resorting to artificial origins. Occam's famous principle suggests that we should look for the simplest explanation that fits the data. Hypothesis 3. Unknown natural phenomenon. The third position, perhaps the most scientifically conservative, was to acknowledge that we may be observing a natural phenomenon that simply has not been documented before. The universe is full of surprises, and interstellar space remains largely unexplored. Perhaps there are classes of interstellar objects with properties that go beyond our current models. Perhaps the extreme conditions of the interstellar environment, high-energy cosmic rays, exposure to objects over billions of years, can create materials and structures that behave in unexpected ways when exposed to solar heat. This hypothesis had the merit of not requiring extraordinary assumptions, but it also did not offer a specific mechanism to explain the observations, making it more of a "we don't know yet" filler than a full-fledged theory. Part 6. Current status. As of October 5, 2025, when this analysis is being recorded, the object continues to move along a trajectory that, according to current calculations, will bring it to its closest approach to Earth at the end of January 2026. At its current course, the distance of the approach will be about 0.12 astronomical units, approximately 18 million kilometers, which is 47 times farther than the Moon. This is not a close approach by planetary defense standards. Objects that pass within 0.05 astronomical units, about 7.5 million kilometers, are classified as potentially hazardous if they are large enough. At its current trajectory, the object is passing by with a comfortable margin of safety. But, and this is a critically important but, the object continues to demonstrate its ability to maneuver. Most recently, a fourth corrective event was recorded, slightly altering the trajectory. The change was small, only a few meters per second of velocity change, but it confirmed that the object remains active. an international observation campaign, coordinated by an informal network of research groups, maintains almost continuous tracking. When the object disappears below the horizon for one observatory, another on the opposite side of the Earth continues the observations. Updated orbital elements are published every 6 hours, allowing astronomers around the world to track any further changes in trajectory. Attempts are being made to establish contact, although this has not been officially reported. Several radio telescopes have directed signals toward the object at various frequencies, including the classic hydrogen band of 1420 MHz, which is often suggested as a universal frequency for interstellar communication. So far, no responses have been detected, nor for that matter any radio emissions from the object itself. The James Webb Space Telescope has scheduled a series of additional observations for March, aimed at obtaining as much spectroscopic detail as possible. Of particular interest is the search for any molecular signatures that could indicate biological processes or artificial chemical compounds. There are also preliminary discussions, very preliminary, with many caveats, about the possibility of sending a spacecraft to rendezvous with the object. The object's current trajectory makes interception technically possible for a spacecraft launched in April or early May, although the delta-v requirements are significant. No space agency has publicly committed to such a mission, but NASA engineers are reportedly conducting feasibility studies. A quick flyby mission could provide close-up images and additional compositional data that cannot be obtained with ground-based telescopes, even if the mission could only confirm that the object is a natural geological body with unusual properties. That alone would be worth the effort. Conclusion: uncertainty and what comes next. We are living in a moment of profound uncertainty. We have an object that does not behave as natural bodies in the solar system should behave, but for which we do not yet have convincing evidence of artificial origin. We have data that raises profound questions, but does not provide definitive answers. Perhaps the most important lesson from the 3I Atlas situation is a reminder of how little we really know about the universe beyond our immediate cosmic neighborhood. Interstellar space remains largely unexplored. We have discovered only 3 interstellar objects: Oumuamua, Comet Borisov, and now 3I Atlas, and each has challenged our expectations in different ways. Oumuamua, with its mysterious non-gravitational acceleration and lack of visible cometary activity. Borisov, with its surprisingly ordinary properties, proving that some interstellar comets behave just like our own. And now 3I Atlas, with its alien chemistry and mysterious detached object that seems to be heading toward us on purpose. The critical question, of course, is what will happen in May. Will the object approach Earth on its current trajectory, and then continue back into interstellar space? Will it perform additional maneuvers that will either bring it closer or push it further away? Does it have any function or purpose that will become apparent when it reaches a certain distance from our planet? We don't know. And it is this uncertainty that is perhaps the most disturbing part of this whole story. Not the immediate threat. Current calculations do not suggest a danger of collision. Nor is it fear of the unknown. Humanity has faced the unknown before. Rather, it is the realization that there may be phenomena in the universe that are completely beyond our current understanding. If the object is natural, what other surprises does interstellar space hold? What other classes of objects might exist that we don't even suspect? If the object is artificial, what is its purpose? Where did it come from? And most importantly, are there others? In the coming weeks, Every major telescope on Earth and in space will likely be pointed at this mysterious wanderer, trying to extract every possible bit of information before it makes its closest approach. Amateur astronomers with backyard equipment will be tracking it alongside the world's greatest observatories. The data will be analyzed, reanalyzed, and discussed in countless scientific papers and conferences. And we will all be watching the sky, wondering what exactly 3i Atlas released into space and why it is heading our way. Perhaps we will soon have answers. Perhaps the object will fly by, and we will never know its true nature, leaving it as just another mystery in a long list of cosmic secrets. Or perhaps, and this is the most intriguing possibility of all, we are on the verge of a discovery that will fundamentally change our understanding of our place in the universe. One thing is certain: the sky will be much more interesting this spring. And when you look at the stars in the coming weeks, remember that somewhere among those points of light is an object that could represent either the strangest natural phenomenon we have ever observed, or perhaps the first confirmed contact with technology beyond our world. Time will tell. In the meantime, we observe, measure, and wait. Stay curious, stay alert, and keep looking at the sky.